Right, so going to go through how to do all of this stuff on this probability assessment for this video. Okay, so first of all, we've got a question on the probability scale. Okay, this is a numerical scale because it's going from 0 up to 1. Okay, so it's asking us for the above scale, decide which letter is used to show the probability of these things. Okay, now it goes up from A to G, so it goes up 1, 2, 3, 4, 5, 6 increments. Okay, it looks like it's out of 7 because there is 7 little dashes, but remember it's 6 increments. Okay, it's going up 6 times. It's not a case of the number of dashes. All right. Now the first one, it says rolling a die and getting a 5. Well, that is one outcome. So one outcome out of 6 because it's your standard die, whatever you want to call it. Okay, so that is one increment out of 6. That would be our B there. Okay. Question B, flipping a coin and getting a tails. That's of course a half chance. What's exactly halfway down our probability scale? It'd be D. Okay. Rolling a die and getting a number higher than 10. Well, you can only get numbers 1 to 6, so it's completely impossible. So what's impossible? It's down here at 0, so that'll be A. And for the last one, rolling a 10-sided die and getting a number less than 150. So less than 150, well, that does include all the numbers 1 to 10. So that's a certainty. It's definitely going to happen. Definitely going to happen? G. Okay. So that's the first one. That is just using the scales. All right. Second one uses a two-way table. So first of all, students were asked to vote on their favourite school trip. So we've got ski trip, water sports, and EAP, and it's split between males and females. Remember, two-way tables, all of the columns have to add up to this total at bottom. All of the rows have to add up to that total at the end. Okay, and these will always add up to this grand total at the bottom there. Okay. First off, then, where should we start? Well, couple of places we could start. We could start either here, we could start there, or we could start there. Okay, we can't start here or here because we don't know what's in there yet. We don't know what's in there yet. We don't know what's in there yet. Okay, and this one, there's 2 blanks as well, so we can't do it. We can only do it where there's kind of 1 blank to start with in a column or a row. All right. My personal preference, I'm going to start here because these look like nice numbers to use. So 120 take away 65 is going to be 55 there. Okay. Next up, what else should we do? These look like easy numbers to use. So 21 plus something equals 45. So 45 take away 21 is going to be 24. Okay. Now, I might start using my calculator just for quickness now because I just don't want to waste anyone's time. So first of all, let's go for 65, take away 7, take away 21. That's going to be 37 for this one. What's going to go here? We're going to have 55, take away 24, take away 16. We're going to get 15 there. 7 and 15 is 22. And 2 different ways we could do that. We could do 37 and 16. 37 add 16 is going to be 53. Another way we could check that is to get that 120, take away the 22, take away the 45. Does that make 53? Yes, it does. Okay, let's quickly check that they all add up properly. So 21 plus 37 plus 7 is indeed 65. Good. 24 plus 16 plus 15 is 55. Good. 21 plus 24 is 45. 37 plus 16. Yep. And 7 plus 15. Yep, that all works. Okay, wonderful. Next one, work out the probability of picking a male student. You must simplify your answer. Okay, probability of getting a male student. Now, which one of these is that? All the male students. Is it that? Nope, that's just the ski trip people. Just the water sports, just the EAP people. So it'll be this one. So 65 out of 120. Is that simplified? Well, no, because that ends in a 5, that ends in a 0. So they're both in the 5 times table. Divide them both by 5, you're going to get 13 out of 24. I can do that in my head. I'm not expecting you to do that. Okay. Right, question 3. Bob and Mary are seeing how many cars are passing that only have one person in them. Okay, so if they only have one person in them, probability for Bob's one, 50 cars passed, probability, well, 0.5, half of them had only one person in them. With Mary, let's have a look. With Mary, 100 cars passed and 0.4 probability of only one person being in there. Okay, so whose data is more reliable and why? Now, if we want reliable data, the more you do, the more reliable it's going to be. Okay, because if you have a look at 1,000 cars passing, that's going to give you really, really accurate data because you've got a bigger sample. Okay, so for 3A, it would be Mary, because there is a larger sample. Larger sample. Oops, larger sample. There we go. For 3B, using Mary's data, how many cars would you expect will only have one person in them if 300 have passed? Well, the probability was 0.4 from Mary's data. And if 300 cars are passing, we'll times that by 300. 0.4 times 300 gives you 120 cars. Okay. Right, question 4. Frequency tree. Let's have a look at this one then. Complete that frequency tree. There's no data, there's no kind of explanation involved. It's just this. It's just adding and subtracting. Okay, so 120 take away 50, 70. 70 take away 33 would give you 37. 50 take away 12 is, of course, 38, and that's completely done. If you make one mistake, you drop 1 mark. If you make 2 mistakes, you don't get any marks, I'm afraid. Okay, right, question 5. Let's have a go at this one then. So, Mark has a bag of counters. In the bag there are 7 black and 3 red. He puts the counters back after drawing them out. Draw a probability tree to represent this information. Okay, so we've got 2 kind of passes on doing this. So there is the first, counter, and then there's the second counter. Okay, first time we've got black or we've got red. Okay, there are 7 black and 3 red, so that is going to be 7. If probability is going to be 7 out of 10. Probability of getting a red one would be 3 out of 10. Now remember, he puts them back in again after drawing them out, so the probabilities of getting black and red are just going to be exactly the same. Okay, 7 out of 10, 3 out of 10, 7 out of 10, 3 out of 10. Okay, easy as that. Alright, so getting that first of all is, so that's 1 mark, 2 marks, 3 marks. Alright, now work out the probability of Mark picking one of each colour when picking 2 counters. One of each colour. So he could have got black and red, or red and then black. Okay, so the probability of getting black and then red would be 7 out of 10 times by 3 out of 10. Remember, this is the AND rule. Okay, so that would come out as 21 out of 100. Now, if you got red and then black, that is going to be pretty much the same thing. 3 out of 10 times by 7 out of 10. Okay, and that will be, again, 21 out of 100. So it's this or that. So when it is this or that, we add them together. So 21, be quiet, 21 out of 100, add 21 out of 100 would be 42 out of 100, or 21 out of 50. Hope it helps. Thank you.